Hello everyone, welcome to the solution of LeetCode problem 958 named check completeness of a binary tree. In this problem, we are given the root of a binary tree and we have to determine if it is a complete binary tree. So here, the definition of the complete binary tree is for every level except possibly the last level is completely filled and all nodes in the last level are as far left as possible, and it can have between 1 to 2 to the power h nodes inclusive at the last level h. So here we can see that for the example 1, the root is 1, which has 2 children, 2 and 3. 2 has 2 children, 4, 5, and 3 has 1 children, which is 6. So here we can see that the first level is complete, the second level is complete, but the third level is incomplete. It should have 4 nodes, but it has 3. But fortunately, all of the 3 nodes are as left as possible, so we have to return true. But in the second example, we can see that in the third level, the last node is as right as possible, because this node 3 can possibly have a left node, but it is missing, so it is not complete binary tree. We have to return false here. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. The root is 1, which has 2 children, 2 and 3. 2 has 2 children, 3 and 1. And 3 has 1 children, which is 4. So here, the left children of the 3 is missing. So it is not complete binary tree. So now let's understand how can we solve it. So here, as we have to deal with the levels, we will use the BFS algorithm. The basic intuition behind the BFS is, if any kind of graph or tree problem, we have to deal with the level, we will simply use the breadth first search algorithm. So here, let's see how the BFS work. In the BFS, let's take a queue data structure. So here, the algorithm starts from this node 1. So we will add 1 into the queue. So this 1 will be the first level. Now let's take a Boolean variable. Let's say x. We will initialize it with true if we find any of the null nodes into the queue. So our front element of the queue is 1. So we have to remove it and we have to insert its both of the left and right children. So the queue will have the value 2 and 3. Now these 2 and 3 are the second level. So here for the 2, which is the front element of the queue, we have to remove it and insert its left subtree, which is 3. And for these 2, we have to insert it right subtree or right node value, which is 1. Now the front element of the queue is 3. We have to remove it and we have to insert its left subtree value, which is initialized with null. Let's make it n, and its right subtree value, which is equal to 4. Okay, so far so good. So we have completed iteration of 2 of the levels. Now these 3, 1, null and 4 are the third level. So the top element of the queue will be 3. We have to remove it, but it does not have any of the left or right children. Actually it has, and all of them are null. So we have to insert null here, 2 nulls. Now the front element of the queue will be 1 and we have to remove it and we have to insert its left and right children, both of them are null, into the queue. Now we have found a null node into the queue. So we have to initialize x with true. Now we have to remove this null and the front element of the queue will be 4, which is in the same level. But wait, we have found a null value. After that, we have found a node which is equal to 4. That means that violates the complete binary tree conditions. So in this case, we have to return false. And here, after completing the iteration, if we did not find any of the node after the null, we have to return true. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named isCompleteTree, which has a root as a parameter. Now, we are taking a queue to store the node and initializing or inserting the root to the queue. And we are taking a variable named null found initialized with false. Now, we are running this loop until the queue becomes empty, and for each of the level, we are calculating the size. And for each of the size, we are taking the front node of the queue and we are removing it. And if the node is null, that means null found should be initialized with true. That means we have found a null in our current level. After that, else, that means this block execute after that if we have found a non-null value. So here, if the null found is true, that means we have found a not null value here, but before that we have found a null value. That means this violates the completeness of the binary tree, so we have to return false. Otherwise, we have to insert the nodes left children and right children to the queue. Finally, if it is not possible or till now our algorithm does not return anything, we have to return true after completeness of the BFS algorithm. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.